Hi, and welcome to another one of my math videos. This time I thought I'd zero in on zero exponents, and specifically, why is any number to the zero power equal to 1? It doesn't seem to make any sense. Well, to explain myself, I'm going to make use of the identity property. And I always thought this was kind of useless, but it says that any number times 1 is itself. So you can multiply by 1, it doesn't change the number. And that should seem pretty obvious because if you take a number, say 12, and multiply it by 1, you get 12, any number. Okay, so then I'll come back to, well, what is the definition of an exponent? And how do you use it? Well, let's take an easy number like 2, and 2 to the third power. 2 to the third power, we commonly know that as 2 times 2 times 2. And I purposely left a little space right here because I'm going to plug something in there. And uh, if I multiply this out, I would get 8, right? Because 2 times 2 times 2 is 8. Well, couldn't I also make use of the identity property here? Right? Any number times 1 is itself. So couldn't I inject a little multiplying by 1 right there? Could I just say, just to be strange, I could say, well, I could multiply this by 1 and I would still get 8, right? I haven't changed anything. I just added a 1 right there. Okay, well, then I'll continue with a pattern because math is all about patterns. And I'll bring this down from 3 to 2. And this would be 2 times 2, which is equal to 4. And of course, I could multiply this by 1, just because. I know it's strange, and I know it's an extra thing to do, but you could. It doesn't change anything. Now I'll continue with my pattern, and I have 2 to the first power. Well, that's just 2, right? And that's equal to 2. And once again, I could multiply that by 1. So if I were to look at this pattern now, I would see that 2 to the third is 2 times 2 is 3 2's being multiplied, and then you can add multiply by 1. Didn't change anything. Here, 2 to the second, 2 of them, multiply by 1. So the exponent is telling you how many 2's you have. Always multiply by 1. So then if you have 2 to the 0 power, that would be, well, how many, the 0 tells you how many 2's you have. I don't have any 2's. I have 1, 2 there. I don't have any 2's, but I still have 1. And so that would be, oops, that would be equal to 1. And further, if you are not convinced, I mean, we can go with the tried and true. If you look at the patterns, I mean, once again, patterns play into this. As you go from 8 to 4, that is division of 2. And you're dividing by 2 because that is your base right there. We're dividing each time by 2. So if I divide this by 2, that's 2. And then 2 divided by 2 is 1. And we can do this with any base. It doesn't matter what it is. I can move this here, and I could just make it 5, and I could just start with 5 to the third. 5 to the third would be 5 times 5 times 5, which is 125. Of course you can multiply by 1. Why not? And this would be 1 times 5 times 5, which is 25. And then this would be first, and this would be 1 times 5, which is 5. And then 5 to the 0 would mean I don't have any 5's, but I still got that 1 right there. And it's 1. And then we could further confirm this as 125 divided by 5 is 25, and 25 divided by 5 is 1, and 5 divided by 5, I'm sorry, 25 divided by 5 is 5, and 5 divided by 5 is 1. And so it doesn't matter what the base is, you're always going to end up with 1 as the result when you're raising something to the 0 power. And so you might be asking the question, well, what happens if I have 5, if I continue this 3, 2, 1, 0, negative 1? Well, now we're talking about negative exponents, and that is the topic of the next video. So check that out.